Hello everyone, this is Saritha, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering. Today's session I am going to explain about definitions and terminology on image segmentation. Here, in this image segmentation, what is meant by segmentation? So what is segmentation? Segmentation is the process by which a digital image partitioned into various subgroups of pixels called image object, which can be called image segmentation, or image object which can reduce the complexity of the image, and thus or analyzing the image becomes simpler. So in this image segmentation, consider one image. So consider one image. So in this entire image, the image size is 3 by 3. Total 9 pixels. In this we are having total 9 pixels. So here whatever we require. So based on that, I need only this portion of my image. So with the use of this segmentation, we split this part from this entire image. So with the use of this segmentation, memory storage can be reduced. So whatever we require, we are storing on that one only. So unwanted can be deleted. So this is the image segmentation. In this image segmentation, in our fourth module image segmentation, in this we are having region growing, region splitting and merging, thresholding technique and gradient operators. So half transform, how we will achieve the local and global processing techniques via half transform. So here in the first image segmentation is the process. It is the process. The entire image can be divided into subgroups. Next, what role does the segmentation play in image processing? So deals here with the use of this image processing, partitioning an image into its constituent parts or objects. So this is my image. So in this image, which part we require, we can divide into multiple groups. So I need this pixel. So I need this one. I need this one only. I need this portion of my image. I need this portion of my image. So with the use of segmentation, we can divide the image into subparts. And what is object? Object in image processing is an identifiable portion of an image that can be interpreted as a single unit. And what is zero in flat segment? So the derivations of digital functions are defined in terms of differences. So the definition we use for first derivative should be 0 in flat segment. What is thresholding? So thresholding, we are representing g of x comma y. So f of x comma y is our input image, and g of x comma y. Here f of x comma y is input image. We are applying the transformation function onto this f of x comma y. Then output is nothing but g of x comma y. This image is m into n only. The image we are representing m into n. This is f of x comma y, and here the output is g of x comma y. Here this output image pixel values, here it is 1. If f of x comma y which is greater than t, here the image consider the gray level values. For example, here the gray level value 0 to 256. If each and every bit we are using L equals to 2 power k, here k equal to 3, means L equal to 2 power 3, which is 2 power 8, means 256. L equals to 256. The gray level value varies from 0 to 255. 0 to 255. So 0 to 255 means the gray level between 0 is the minimum gray level, 255 is the maximum gray level. maximum gray level. Here minimum gray level, this is maximum gray level. If I am assigning the threshold value, here it is, for example, here it is 128. So whose pixel value, the threshold value which is greater than 128, here the threshold value is 128, here greater than 128. So f of x comma y greater than 128, then those pixels are represented with 1, and less than 128, those pixels are represented with 0. So this is the thresholding. So with the use of this thresholding, we can region with the use of this thresholding, we will detect the boundaries of an image. So next one, write the applications of segmentation. So here, detection of isolated points, detection of lines and edges in an image. So segmentation. So what are the applications in our segmentation? If any image is there, so I need to find the vertical lines, horizontal lines and vertical lines, and here find the edges of an image, find the edges of an image. So with the use of segmentation, detection of isolated points and detection of lines and edges in an image. And next one, define non-zero response at onset of gray level line. So the derivation of distal functions are defined in terms of differences. So here with the use of non-zero response at onset of gray levels, here the definition we use, the second derivative should be 0 in flat segments and 0 onset gray level step or ramp, non-zero along the ramps. So here gray levels are non-zero if consider the ramp signal. So gray level line. So the gray level line, in this we are having how to find the edges. In this edge detection we are having line, ramp, and in this line, ramp, edges are the roof. So in this we are having different types of detection of edges are the line edge, ramp edge, roof edge. And what are the three types of discontinuity in digital images? So first one is points, lines and edges. So in these points, edges, how to find detect the points in an image. Next, lines in an image. So lines means we can vertical lines and horizontal lines. So how to find the vertical lines and horizontal lines, and edges of an image. So how to find the lines and edges of an image. So discontinuity is nothing but in a image processing, similarity and discontinuity. So similarity means consider an image, adjacent pixels and neighboring pixels are same gray level, then it is similarity. Discontinuity means adjacent pixels or neighboring pixels are different with gray levels, then some discontinuity will be occurred. So how to detect the discontinuity in an digital image means based on points, lines and edges. So applications of image segmentation, this is content-based image retrieval, machine vision and medical imaging, including volume rendered images from computer tomography and magnetic resonance imaging, object detection, recognition task, traffic control and video surveillance and video surveillance. These are the applications of image segmentation. Next, how the derivatives are obtained in edge detection during formulation. Here, the first derivative at any in an image is obtained by using the magnitude of the gradient at that point. Similarly, second derivative also obtained by using the Laplacian. So in this gradient operator, so how to detect the images with the use of gradient operator, how to detect the edge detection. So in this dou f by dou x and dou f by dou y. So with the use of this derivative operator, we can detect the vertical and horizontal lines of an image. Here, dou f by dou x plus dou f by dou y. It scans vertical and horizontal lines in an image. Define noise point. Image noise is random variation of brightness or color information in images and is usually an aspect of electronic noise. It can be produced by the image. So isolated points is also called as noise points. So noise is nothing but it is a high frequency signal. So here if we consider any image, when we go for any histogram, this is my input graph. So some points it reaches its maximum level. So it is nothing but short noise. So those noises here, image noise in random variation of brightness, or color information in images. So image noise is random variation, randomly vary. For example, consider in image. So noise is randomly variation of brightness or color information in images and is usually an aspect of electronic noise. So it can be produced by the image. Isolated point is also called as noise point. Write about linking edge points. Here, the approach for linking edge points to analyze the characteristics of pixels in a small neighborhood. So here the image we are representing here, the size is 3 by 3 or 5 by 5 is the filter mask. Here about every point we are representing with x comma y in an image that has undergoes edge detection. So here how to find the linking edge or edge linking. So here linking edge points is to analyze the characteristics of pixels in a small neighborhood. So that is we are representing 3 by 3 or 5 by 5 about every point x comma y. Define thicker. The first order derivatives produce thicker edges and the second order derivatives produce much finer edges. What are the two properties used for establishing similarity of edge pixels? Here, first one is the strength of the response of the gradient operator used to produce the edge pixel, and second one is direction of gradient. So two properties used for establishing similarity of edge pixels. First one, strength of the response of the gradient operator, and second one is direction of gradient. What is edge? Edge are significant local changes in the image and are important feature for analyzing the image. So edge is nothing but consider any image. In that image, some pixels are same gray level, some other pixels are with a different gray level. So in this we are finding the edges. We are based on that gray level, we are finding the edges of an image. So what are the two properties used for establishing the similarity of edge pixels? So here the strength of the response of the gradient operator used to produce the edge pixel and direction of gradient. Define pixel density. So here pixel density is a calculation the return the number of physical pixels per inch on a screen or display of a device. So define pixel density means number of pixels we are using in that image, and pixel density is a calculation of return number of physical pixels per inch. So consider any TV screen. So when TV screen per inch on a screen. So physical pixels per inch on a screen or display of a device. Give the properties of second derivative around an edge. So the sign of the second derivative can be used to determine whether an edge pixel lies on the dark or light side of an edge. So it produces two values for every edge in an image. So define gradient operator. So the gradient operator of an image, we are representing the image is f of x comma y. At location x comma y is defined as the vector magnitude of the vector. So here f of x comma y. So if we are considering the image, this location we are representing with x comma y. Define object point and background point. Here to execute the objects from the background is to select a threshold t that separates these modes, and then any point x comma y for which f of x comma y is greater than t is called object point, and otherwise it's called the background point. So here how we can detect the object and background point means assign some threshold value whose pixel values are greater than that is a background or object, and remaining are background. So here then any point x comma y for which f of x comma y is greater than t is called an object point, otherwise the point is called background point. What is global threshold? So when t depends only on f of x comma y, then the threshold is called global thresholding. So threshold value means here threshold, in this we are having global threshold, global and local thresholding is there. So global processing and local processing. Global processing is nothing but here we need to consider the gray levels of entire image. So in local processing means we are considering only sub image of in that overall image. Define region growing. In this region growing is a procedure that groups pixel or subregions into layer regions based on predefined criteria. So in this region growing, for example, this is my image. So here the gray level is 1. If so entire in this image, this pixel value is 1. Here also pixel value is 1. Here also 1. This pixel value is 0. So here this pixel value is 1 and this pixel value is also 1. So the region is increased to added one more pixel. Here also the region value is 1, add this pixel also. For example, here also the pixel value is 1, add one more pixel. So like that in region growing is a procedure that groups pixels or subregions into layer regions based on predefined criteria. And specify the steps involved in splitting and merging. So in this splitting and merging, split into 4 disjoint quadrants any region Ri for which P is the pixel, Ri is false. Merge any adjacent region Rj, and Rk for which P of Rj union with Rk it is true. So stop here. Region splitting and region merging means here, for example, one image. So this image is different gray level and this portion is this is entire image. This part is one gray level and here it is another gray level. So in region splitting, the first step we need to divide into quadrant parts. So divide into 4 parts. So here the portion divided into 4 parts. In this is splitting. In this splitting, these two are same gray levels and these two portions are same gray level. Again, merging apply the merge operation means these two are same gray level means merge this portion, and these two are same gray level means merge this portion. So this is my input image. This is my input image. In this input image, this portion is one gray level and this portion is one gray level. So how to do the splitting operation? First split into quadrant, then 4 parts. In these 4 parts, this is region R1. For example, this is R2. This region is R2, R3. This region is R4. Here, observe in R1, entire region is same gray level. So, no need to split. Same gray level. Here, no need to split. Here also, this region is also same gray level. So, no need to split. Here, R3 region also, this entire portion is same gray level. Here also, no need. In R4 region is also no need. So, here splitting is not required here. Up to this next stage, splitting is not required. So, we are going to match the region. So, these two portions are same. These two regions are same gray level. So, merge these two, and these two regions are same. So, merge these two. So, this is the splitting and merging procedure. So, for example, if in this region, this portion is with different gray level and this portion is different, means again we need to split into 4 parts. Here also we are split into 4 parts. So, like that condition, if it is possible, then again we are splitting. If it is not possible, splitting is not required, then go to the merge operation. What is local thresholding? If the local thresholding T depends on both f of x comma y and p of x comma y is called local thresholding. So, in this local thresholding, f of x comma y is nothing but our image. So, this image I am representing with f of x comma y. P of x comma y means each and every pixel we are representing with p of x comma y, p1 of x comma p2 of x. It is depends on here the thresholding, local thresholding depends on both f of x comma y and p of x comma y is called local thresholding. What is dynamic or adaptive thresholding? So, if threshold T depends on the spatial coordinates x and y, the threshold is called dynamic or adaptive, where f of x comma y is the original image. So, the thresholding T depends on the spatial coordinates x and y. So, that thresholding is called dynamic or adaptive, where f of x comma y is the original image. So, how edges are linked through half transform? Here, the edges are linked through half transform by using intersecting of two line equations. So, in this half transform, first find the straight line. So, y equals to mx plus c. Based on this is a straight line. If I am going to connect any points, so it is the shortest point. So, like that in half transform, the straight line equation is y equals to mx plus b. So, the edges are linked through half transform by using intersecting of two lines equations. The straight line equation is y equals to mx plus b. And what is object recognition in image processing? So, object recognition consists of recognizing, identifying, and locating object within a picture with a given degree of confidence. So, here object recognition consists of recognizing, identifying, and locating objects within a picture with a given degree of confidence. And what are the factors affecting the accuracy of region growing? Here, the factors affecting the accuracy of region growing are like lighting variation, pixels intensity value. So, in this region growing technique, whose pixel values are same, we are adding one by one pixels, the region is increased. So, in this image, this pixel value is same. 1, for example. Here, for example, 20. Here, 10. So, here, 19. Here, 19. Here, region growing technique. So here the variation from this pixel to this pixel is only small variation. So here based on this lighting variation or pixel intensity values, sometimes we are unable to grow the region. So here these are the factors affecting on our region growing. So first one is lighting variation and second one is pixels intensity value. Define region splitting and merging. So region splitting and merging is a segmentation process in which an image is initially subdivided into a set of arbitrary or disjoint regions, and then the regions are merged and are splitted to satisfy the basic condition. What are the image segmentation techniques? So the various segmentation techniques based on the first one is gray level. So segmentation techniques in this we are having two: discontinuity and the second one is similarity. Here the various segmentation techniques based on gray level discontinuity and gray level similarity as well as depicted in a graph. What is the cause of ringing effect? So in this ringing effect occurred in sampling rate. So does not include all frequencies in your image. Ringing effect is occur. So if you when we go for sampling means the image is converted into analog to digital. First we are going to do the sampling technique. So in this sampling technique, first continuous signal can be converted into number of samples. So in these samples not included this sampling rate fs greater than or equals to 2 fm. So this sampling rate does not include all frequencies in your image. The ringing effect occurs. And what problem occur when the histogram has only one lobe? Here when the image histogram has only one lobe, then a threshold cannot be found. So one lobe, if a histogram has one lobe, then histogram cannot be, thresholding cannot be found. And what problem occurs when the image has low luminance? Then the histogram of the image is restricted to a small region. So of luminance intensity and uniform thresholding does not give good result. So here in this we are restricting the histogram. So histogram means it increase the contrast level. So in initially my image graph is like this only. So I am applying the histogram equalization, then the histogram it covers the entire portion. So this is the histogram process. So up to here it has in this only. So we are applying the histogram equalization process. Then my image contrast is increased. So it covers entire region. So for example, if you are restricted, histogram of the image is restricted to small region of luminance intensity and uniform thresholding does not give good results. Next, what are the advantages of non-uniform thresholding? So in non-uniform thresholding, solve the above mentioned problem. In this we are having uniform thresholding does not give the result since it first modify the histogram in order to better distributed and illuminance values. So what is the definition of pixel neighborhood? So in many applications it is important to check connectedness of region smoothing that is done using the neighborhood definition. And next, what are the two approaches to segmentation? Region-based segmentation and edge-based segmentation. So in region-based segmentation and edge-based segmentation, in region-based segmentation we are having region growing, region splitting and region merging. So in edge-based, how to detect the edges means in this we are going to use edge detection. So in this edge detection we are using Sobel filter, edge linking detection we are using Sobel kernel, and private Robert. So with the use of these three kernels, we can detect the edges of an image. So what is line and edge detection? So line and edge detection is basically the process of finding all lines and edges of interest of an image. So line and edge detection. So in the entire image where we require to find the edges or lines of an image, so finding the line and edge detection is basically the process of finding all lines and edges of interest in an image. What is edge detection is used? In edge detection in an image processing technique for finding the boundaries of object within image. So in this edge detection, finding the boundaries of an image, and it works by detecting the discontinuous in brightness. So how to find the edges of an image means if each and every pixel, so here, so in this pixel whose gray level values are in adjacent pixels also same gray level, then it is in continuous. If it is not differ with adjacent pixels and this pixel gray level are differ means find some edge between these two pixels. So edge detection is used for image segmentation and data extraction in areas such as image processing, computer vision and machine vision. How does a Sobel filter will works? So in this, how does Sobel filter works means the Sobel filter is used for edge detection. Sobel filter is basically used for edge detection. In this edge detection, we can go for line edge. So in edge linking process, in line edge, we are having different types in line edge detection. First one is roof edge. So roof edge means, so up to here, gray level is gradually increases. Some extent it reaches to previous gray level value and step change. So step change means here the gray level value. So the gray level value up to some extent it is same. Again it enters into another gray level value. Another gray level value again it reaches into previous one. And next one is ramp change. So ramp changes gradually changes their gray level value. So for example, consider a gray scale. Here it is 0 to L minus 1. L is nothing but number of bits we are using each and every pixel. So L minus 1. Here the scale. So here for example it is dark. So her white. Here some gray color. So here some thick. Here maximum thick. So here the changes of gray level gradually. The gray level is changes gradually from one pixel to another pixel. And here in the Sobel filter, will works means it works by calculating the gradient of image intensity at each pixel within the image. So it finds the direction of the largest increases from the light to dark and rate of change of the direction. So in this Sobel filter mask, consider one filter. So in this filter 0 0 0 here minus 2 minus 2 minus 2 2 2 2. So the sum of all the pixel values are which is equal to 0 only. It maintains the constant gray level value. With the use of this filter, we can scan the vertical lines and horizontal lines. So depending on if I need to scan plus 45 degrees or minus 45 degrees, for that case I am using 1 1 1 here minus 1 minus 1 minus 1 0 0 0, and we are scanning either plus 45 or minus 45 here 1 1 1 here minus 1 minus 1 1 remaining pixels are 0. So with the use of this Sobel filter mask, we are applying this mask in our original image. It scans the plus 45 degrees and minus 45 degrees vertical lines and horizontal lines of an image. And what is Robert Edge? So here the Robert Edge filter is used to detect edges based applying horizontal and vertical filter in sequence. And next one is, what is private edge detection? So in this private operator is used to in image processing, particularly within the edge detection algorithm. So technically it is a discrete differentiation operator computing an approximation of the gradient of the image intensity function. So in this image segmentation, we are having two types of similarity and discontinuity. So here in similarity means that image, all the pixel values are same, that is in similar. Discontinuity is nothing but adjacent pixel values are different, then that is a discontinuity. How to find the detection of discontinuities in our image? So how to find the detection of discontinuity in our image means we are having local processing and global processing, and how to find the edges or vertical lines and horizontal lines of an image means with the use of Sobel mask, robot and private mask filters. And here and another one is region oriented segmentation. So what is mean by region oriented segmentation? In this region oriented segmentation we are having region splitting and region merging and region growing. So with the use of these three techniques we can splitting. How to do the splitting means depending on gray level values. So if any image, this is one region, if any image is there, so I want to split that image means, so here divide into four parts. So in these four parts, this is region 1, here it is region 2, here it is region 3, here it is region 4. So in these four regions, if this region is same gray level, no need to split. This region is same gray level, no need to split. This region is also same gray level, no need to split. This region is same gray level, no need to split. If in these regions gray levels are differ, then again we need to split. If gray levels are same, then merge this portion. Again split in R2 region, split into four parts. For example, this portion is same gray level with R1, R2, R3. Then add this portion. So this is the merge operation. And based on gray level splitting, here it is a splitting operation. Region growing means whose pixel values are same gray level, add those pixel values are one by one, then find the entire image output. This is the region splitting, merging and region growing. And one more here, after this region splitting and merging, we can go for thresholding. With the use of thresholding, how to split the image? So how to segment in our segmentation, thresholding is very, very important. How to split the entire image into subparts? So for that case, we are assigning the threshold value. For example, multiple images are there. So this is one image, this is one image, this one is one image. So how we can split into three images in consider is a one, how we can split into individual images? Here assign, for example, this circle, the threshold value, for example, here it is 30, and for this square threshold value is 50, for this threshold value is 70. So assign each and every image, consider a threshold value. So in case 1, the image value here, the threshold value 0 to 30 represent with 1, remaining all 0. So at that time we are getting only zeros. Circle. So 30 to 50, whose pixel value 30 to 50 are based on that ranges, based on the threshold value, we are splitting into multiple images into single image. So this is the threshold. In this threshold value, f of x comma y is input image, and we are applying the transformation function, then output image is g of x comma y. In g of x comma y is 1 when f of x comma y which is greater than threshold value. If g of x comma y is 0, when it is 0 means f of x comma y which is less than threshold value. So based on this threshold value, we can divide the entire image into subparts. And here, local processing and global processing. Global processing is nothing but we are considering the entire image gray levels, and in local processing, we are considering f of x comma y and p of x comma y. And here with the use of filters, we can detecting the edges, edge detection with the use of Sobel filter, Robert filter, and private edge detection. So these are the definitions and terminologies of our image segmentation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.